I'm Jack Payne, and this is the Road to Rocketry. Hello and welcome back to another episode. Today we're going to be looking at my electric skateboard that I've previously built. Just tearing it down and having a look at all the electronics inside, seeing what knowledge we can take from my skateboard project and put it in towards the bike project that we're going to be doing, and just basically looking at things that I've done wrong and things that I could do better, and hopefully showing you guys how to make your own electric skateboard along the way. So what we're going to start with is getting the shroud off from the electric skateboard, which I actually haven't done for nearly a year now since it died, and just having a look to see where the points of failure were and what I suspect them to be, and then what they actually have turned out to be. So I actually thought that I blew up the ESC and maybe one or two capacitors have exploded, because I tried to go up a massive hill. It drew loads and loads of current through the ESC, and I think it blew up the ESC because of that. So let's get to it, let's have a look, and let's tear down my old electric skateboard. Okay, so this is the skateboard. So we have, like I said in the last video, the drive system and the electronics, which are in this aluminium pan lid shroud. So yeah, I've literally taken an old pan lid, got an angle grinder, taken off the handle, and just ground it down into a kind of box shape. So what I'll do now is I'll set up the camera into a decent position and we'll tear down this electric skateboard. Okay, so I've set the camera up to try and make it a little bit better. And what we're going to do is I'm just going to pull this off if I can. But pretty tight from being stuck on for a year. Here we go, here's all the electronics. We have the main part where I've plugged the battery directly into the system. We have a little switch up here. We have our battery along here, this big green bit. And then we have the ESC down in here. If I have a look down here, take some of this tape off, you'll actually see that here in the back is my old radio transmitter and receiver. So I use this radio chip here in the top right to communicate with a handheld controller to actually control the motor and how fast I wanted to travel. If I get a close-up view, I'm sorry it won't be as stable because I'm going to try and hold it so I can show you the internals a little bit better. So we have our ESC just here. So this was the speed controller and it's a little bit floppy. Now what I'm going to do is I'm going to quickly stop and take all this Gorilla Tape off so we can have a closer look. Right, okay, so I just I was pulling this apart and all of a sudden I flicked the switch and I was trying to pull the switch out and this happened. So there is some power in this unit because that is the motor trying to connect up with radio receiver, and it's obviously trying to pair up with the remote, but I don't have the remote on me. The remote's not actually on this property, so I wouldn't actually be able to connect it. I'm just going to turn it off. It's a waste of power anyway. So we know that the battery isn't dead, so we could actually use that in future projects. And it's actually going to be bigger than the little batteries I've bought for the bike. So the bikes are only 4000s. Well, this is a 5200 milliamp hour or a 5.2 amp hour battery. However, it's only a 4-cell and the voltage count is actually relatively low for the battery. So I'm surprised we actually managed to get 30 miles an hour out of this. So obviously this motor is rated for 580 turns per volt, and this only has 14.8 volts. So that means that's going about 1000 RPM. That's spinning pretty quick. So if we can get that with such a low voltage, and go 30 miles an hour with such a low voltage, then think of what we can achieve with nearly 70 volts. So that's nearly 3 to 4 times as much voltage as this system's had. But then again, it's about 3 to 4 times less kV. So we will have more torque, a lot more torque, and around about the same speed as this motor was spinning with this setup. And since we have such a big wheel on the other system, I reckon we could really actually achieve really high speeds of 40 plus miles per hour. So I'm going to continue the time lapse here. Just wanted to tell you about this and then finish off pulling apart the system. Okay, so now I've actually managed to pull apart the whole system, and as you can see, this is the metal shroud made out of this aluminium lid. So yeah, that can be thrown over there. Don't need that. And I've managed to separate the battery quite well. So let's have a look at this battery. So this is a multi-star, high-capacity, multi-rotor battery. So obviously with our bike, we've got 6-cell batteries, which are blue. The higher the cell count is usually the higher the voltage, and we want more voltage for a motor rather than higher capacity, because lower cell batteries tend to have higher current rates than larger cell count batteries, and that's because of the different voltages that different cell counts can output. So if we take a look at the ESC, which is connected to the motor, and another problem that I've done is directly soldered the motor and ESC together, so they're permanently connected at the moment. One of the problems with this setup was that basically there's been too much current through this, and it's caused it to explode, and some of the dielectric is shot out through the top of the capacitor, and you can actually see a bit on the wire, and there's some on my hands which I've picked up from taking this apart. Not only can you see it's damaged in that respect, but we can see into the ESC now, and we can see that it's melted away the rubber around the edge, because this is only rated for 200 degrees Celsius, which means this thing must have got very, very hot very, very quickly going up that hill. Probably did a really, really good job at just managing to hold on, and then all of a sudden, boom, two capacitors exploded because it just had too much current flowing through it. For the bike, it can't take 200 amps like this ESC can. It can only take 120. But that doesn't matter, because I've learned a lot from this system and how you want to keep the current as low as possible and the voltage as high as possible to get decent speeds and for your system to work properly. So now what I'm going to talk to you about is how you can make one yourself. So this system probably cost £300 to make, and that's on a budget. So the most expensive part was actually the battery at the back there. So that battery is about £45, give or take. That's the most expensive part you're going to buy. The motor is then around about the same. So this is a little 50-50, so that's the dimension. So it's a 50 by 50 cylinder, and then it had the kilovolts of 580 kilovolt. Now I would recommend a slightly lower kilovolt than this, because it would draw less current and less likely to blow up your ESC. Now you've got to check what cell count your motor will use, and then check that against your battery, and that's the most important thing. If you can connect the two together and have exactly the amount of cells for your battery as your motor won't draw extra current to get the voltage it needs. And that's the most important thing about making an electrical circuit. The second most important thing to preventing a system to go wrong is making sure your ESC is rated higher in amps or max loading than your motor can actually take. Now this took about 80 amps, so I got a 200 amp ESC. Obviously, because I didn't have the correct battery with the cell count, it drew more current than it actually specified on the specifications, which is quite amazing not to see that this motor burnt out, because usually you'll see a motor burn out before an ESC will that's rated at nearly over twice the amount of amps that the motor's rated at. So once you have figured out which components you need, it's very, very easy to connect up an electrical circuit. So what you'll need is a wireless transmitter, which you can get with any radio controlled remote. They will always come with one of these little boxes, and you will need a switch as well, and that is literally all you need for a system like this. A battery, a motor, an ESC, a switch, and a wireless receiver, which you get with a remote. So to connect them up, it's very easy. So I made a mistake. You want to use bullet connectors in the connections here, so you can swap and change everything. I did not do that. I soldered it directly, which was one of my biggest mistakes. So it doesn't necessarily matter which way round you connect these, but they will come out as a 3, look, so 1, 2, 3, and it will do the same on the motor, 1, 2, 3. Now, it doesn't matter if, so this one's a yellow, black, red, and these are all black. And the reason these are all black is because it doesn't actually matter. You might get black, 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 yellow, black, red, whatever, it doesn't matter. Just as long as the middle one's connected to the middle one, it's fine to have these two switched around or whatever. If you have the motor wired up round the wrong way, all it will do is spin in the opposite direction to the way you want it. and that isn't a problem, because then you can just, if you have bullet connectors, just switch the outer two around and it will then run the right way. So once you've figured out how to mount the motor to the ESC, it's very easy from there on. Well, I say it's very easy, but yeah, it kind of is. That was the hardest part I found. So your ESC comes with one of these little 3 pins, and that just plugs straight into your transmitter, and you've got to just fiddle around and find the right channel that you want to use with your receiver. Now there's, I think, 4 or 5 channels. No, there's 4 channels there. Each channel represents a button on your wireless controller. Okay, so then what you do, you have your ESC, and you have these 2 cables coming out the back of it. Now this is kind of hard to show you because it's all a bit mashed together, stuck down with tape. So here, let me just pull it apart. So you've got these 2 cables coming out the back with this little one that plugs into your receiver. Now these 2, I added in a switch and I added in a little battery connector. So this is a TX90 or TX60, depending on how big your battery is, it will need a different size connector. But this is a TX60, so that's what I've used. So the black wire will need to go into the negative side, which tends to be this kind of coned circular side of the connector, and the red one will end up going into the positive, which is the flat side. If you see that, there's a flat side and a cone side. Now what we do is we have this red cable coming along, and it goes into a switch. So it has 2 pins, one here and one here. So you run your red directly into one pin, which is the positive, and then you'll just get another little bit of cable and you run that from the negative into the positive of your XT90. Because remember, this is technically still the red cable, I just didn't have any red wire, I had to use blue. So that just goes straight into the other side. So first thing you do, wire up the black, get the black out of the way, and then obviously anything else you do goes into the remaining slot on the XT90, and that then will connect into your battery. So these 2 connect. Now they will spark if I put them in, so I'm not going to, because these are not anti-spark connectors. You can get anti-spark XT90s, these are not the anti-spark variety. So the reason you want to add in a switch is because you want to be able to control when the battery's on and off. Because if you don't have a shut-off switch, then it will just drain your battery, obviously, and it will be on the entire time with your battery draining. Okay, so that's basically it for the electronics of your electric skateboard. So if you follow this video and use this as a reference, you should be able to make your own. I mean, it's not rocket science. It looks very, very difficult when someone else is doing it, but it's actually not too hard. The hardest part is mounting it to the skateboard, figuring out a way to mount the motor to get that to turn a pulley in tension, and just actually mounting it onto the device that you want to power is the hardest part. This electric system is the most basic system you could possibly have. So don't be worried about how hard it looks, because actually it's really, really simple, and anyone can do it. Now the only limiting factor to this is obviously money. Money is always a problem, but you see all these electric skateboards and they go for about 1,200 quid, and to be honest, they're no different to this. I mean, they look nicer, don't get me wrong, they are a lot more pretty to look at, but they're no different to this. This is exactly the same way they would engineer it, but they would have obviously the correct battery for their motor. So yeah, that's it for today's episode. I hope you enjoyed. I hope you've learned something about how to make an electric skateboard. Feel free to subscribe, because all the help I can get from the YouTube community helps me out so much and allows me to make new videos and gives me new ideas and just helps me make my projects better. So if you've got any suggestions on any videos that I've done, please feel free to leave a comment, because I will read every single comment and take all of your advice and tips on board. You've come to interrupt my video. I've just been doing my electric skateboard.